All right, so as I was saying, I thought that what I could better spend time today would be to go back and go through those chapters. As I said, you can use your notes, the notes you take in class, or the notes you take from reading the text, or the notes from looking at the lecture slides. You can't make copies of the book. You can't make copy of the lecture slides. Again, so many times the lecture slides are just bullet points anyway. So you would have hopefully at the time taken notes in addition to that. So, and I apologize, the last class, the quality of the slides, those projectors are just driving me crazy. I can't find one in any of those rooms that where the picture looks good. I can't decide if my eyesight's getting worse or it really is bad, but I'm gonna have to somehow fix that, get that taken care of. So that's what I thought I would do today. I thought I would do a review over chapters 1 through 7, which is what's going to be on the midterm, and answer any questions you have and go over any material you have. And I have some sample type questions that you might see. There'll be a number of multiple choice questions on the exam, and they all come from a pool. So you may see some questions today similar on the exam, or you may not. It's just because, like I said, you're pulling all these questions from a pool. So 6, 12, 16, 28, 36 multiple choice. 36. Okay, so and then you have an hour and a half to do the exam. It's in the classroom, either in there. We've been in, it's either going to be in 142 or to be in 105, one of those rooms. I'll have a note up on the door somewhere. I would imagine you guys will be there a few minutes early anyway. I hope so you don't rush in at the last minute, have to sit down and take the exam. But, I'll be around, and I'll let you guys know where the exam is going to be. So does anybody have any questions so far about anything to do, with the exam? Or, I'll get into the material in just a second. We can talk about that. But let's see, there's also what I call a jumbled sentence questions, kind of a fill in the blank kind of thing. There's a couple of what I call visual questions. There's a few of those where I show you pictures, many times from your book, or sometimes from pictures that represent something from your book. It would be obvious, and I ask you to identify it. Tell me what that is. There are 2 essay questions that you'll have, 75-word essay questions, right? So what's that, short answer? That's not even really essay questions, but I do expect a complete answer. So make sure that you don't give me just simple little bullet points. I appreciate succinctness, right? I appreciate being to the point. Succinct is the word I was trying to say till my tongue tripped up. But I do expect you to demonstrate you understand the concept, okay? So when you write your answers out, it doesn't have to be in great English composition to sentence structure, but at least pay attention to the basic rules of grammar, especially if it gets to the point where your grammar or your misspellings detract from the clarity of your answer. If I'm like, I just can't make out what this is, right? Then I have to, if I don't know what it is, then I have to say you didn't answer that part of the question, right? So, Chantel, did you have a question? You said yep, or a specific question? No? Okay. So you all understand what I mean about the essay questions. Give me enough. Like I said, there's 75 words. I mean, holy cow, you can easily, so that, again, that's more like a short answer. And I do have a rubric that I'll be using to grade them. And let me take a look at it. I have more than one, so I'm going to see which one. All right, first of all, the rubric, if you want to know what I'm going to grade you on the essays, here's what I'm going to grade you on. I'm going to grade you on whether you wrote enough words, all right? I know that seems a silly thing to do, but it isn't, because it tells me something about the amount of effort you put into the answer, and it avoids folks getting away with saying things like, well, I answered the question. It's kind of like, Oh, what's a good example? If I ask my son, how's your day at work? Good. I get it, right? Sometimes you answer that way, but that doesn't give me much to know whether your day was really good. So if I were to ask you the questions like, describe some of the early explorers, in marine science, the Greeks and the Romans and the Phoenicians and all those that we talked about. And you gave me one little sentence of, it was very popular to sail around the Mediterranean and stay near shore. And then folks started sailing around the southern end of Africa. Come on, expand a little bit more. Give me some names that you know. As I said, you're going to be, yeah, I'm sorry, Amy, I didn't see your question. Yeah, it's Monday. Oh, I see. Thank you, Chantel. You answered it for her. I got to keep my eye on the chat box there. So I want you to give me enough, and again, it's 75 words, so no big deal. I will also, part of the rubric is what I call organization, grammar, and punctuation. That's just what I was talking about. It's the fact that if you misuse a verb here and there, misspell a word, as long as it's a very close facsimile of the word, I'm usually not going to ding you on it. I'm mostly going to ding you if I just can't figure out what you're saying. And what I'll do sometimes on your essay questions is down below, I'll paste something else. I didn't quite get what you meant here. And oftentimes it's some grammatical error, and I'm like, but that's, grammar is one of those things that was never particularly interesting to learn in school, but as you get on in life, you realize how important it is, especially when you got a job like mine where you have to read what other people write. And you're like, yeah, I'm not sure what you're saying there. So there's points on that. There's points on what I call structural and process terminology. It's my way of saying I need a little bit more than, okay, well, during subduction, one of them goes underneath the other, and then it makes the other one make these buckling things, and sometimes that makes volcanoes. It's like, what are you talking about here? Well, when the lithospheric plates crash together and subduction occurs, the more dense plate sinks beneath. The heat and the friction causes volcanic formation, right? You see what I mean there? So it's like using the right words and using those words correctly. And in that mix, too, is the idea of, whether you talk about everything in the question. Sometimes the question will say, look at this and explain this, then tell me about that, right? And I just kind of did what I told you not to do, but you understand the idea. I'm using a sort of a template there. And what I want you to do in the question then is I want you to, fully flesh out your answer. And again, tie it together. Don't give me a bunch of choppy sentences. I know you guys can write well enough. I need stuff that flows together. Make it sound like an answer to a question rather than just robotic, sort of like you memorized a bunch of points, or memorize, a bunch of points. And at the end, and what's worth the most points in the rubric is something I call evidence of overall concept proficiency. Don't you love these titles that I made up? But what that is I'm reading the question, and I'm reading it in mind that you're teaching me something. I don't know about subduction. Okay, I don't know about the Coriolis effect, and I need to learn about it from you. So you're going to explain. You're going to, in 75 words, as if I had just dropped on the planet, was asking about what's this Coriolis effect, right? I don't know why I did that with a Spanish accent, but nonetheless, so your answer, your essay answer must convey that, and that's what I mean. Overall concept proficiency. You understand the concept well enough to explain it to somebody else. Now, one of the best ways to practice doing this is, if you wanted to do it for the Coriolis effect, write it out, okay? Practice writing those kinds of things out, or tell it to somebody, right? So that you feel comfortable with the information, and that's what I mean by that concept proficiency. So that's kind of a scale. I for example, the most points, I'm telling you, according to my rubric, that you're proficient beyond the minimum acceptable level. You have a lot of indications. So in other words, there are several times in there that you hit on the points correctly, you describe them correctly, and then it goes down. And the lowest one is few, if any, clear indicators that you know what the hell you're talking about, right? something like that. If you have any indicators that you have an acceptable level of proficiency. Pardon my French. Okay, so you understand what I mean about giving those essay questions their due diligence. I mean, again, I'm not expecting you to write for 75 points. It's kind of like, for 75 points, I'm not looking for a dissertation. Or for 75 words, I'm sorry. I'm not looking for a dissertation. But I do expect it to be a complete answer and it to make sense. Please make it make sense. The hardest thing for me to do is to sit at home and go, what is she trying to say here? What is he trying to say here? Because I'm trying to help you out, trying to understand, okay, these are folks who are trying to explain this stuff sometimes for the first time in their lives. So, I'm trying to give you the benefit of the doubt, but you gotta meet me halfway. Any questions so far? Am I just rambling, or is this helping, making sense? I always get questions about what can I do to study for exams, and that's always, or what can I do to get ready for exams, and I usually just say, well, get ready for them. Anything specific I can do? I mean, I'm not going to give you the questions, but if there's anything else, do you all want to see a few sample questions of this type that you might see, so you get an idea what they look like? Okay, let's see. I'll go by chapter. So, all right, I got a bunch of chapter 1 questions. Now, some of these will be on your exam. Some are in the pool. Some are old chapter 1 questions from other times when I've taught this class. Some are just mixtures of questions. So if you go, hey, none of those are on the exam, well, that's, they're not supposed to be. Well, yeah, I'm not going to sit here and give you the exam questions right off the top. There may be a few of them that are similar. All right, here's one. I'll put it in the chat box. It's easier that way. So the Earth has 4 principal ocean basins, and then one more that we throw in there. Could you name all 4 of those, or could you name, the 5 of those? Yeah, see what I mean? So, and that would be an example of a multiple choice question. And I would give you ones like, I would give you the correct answer would be what you see here, the Atlantic, the Pacific, the Indian Ocean, the Arctic Ocean, and then the Southern. The one that people tend to forget about is the Southern Ocean, because remember, it's not really an ocean unto itself. Not that any of these are. They're all connected to some degree, but there are continents between them, whereas the Southern Ocean is basically just the waters, as it says, that are defined by the Antarctic convergence, right? It's just kind of that southern latitude area. Okay, and then I might throw other ones in there to throw you off. I would say the Antarctic Ocean. Well, there isn't an Antarctic Ocean. I might call a Caspian Ocean. Well, there's a Caspian Sea, but there's no Caspian Ocean. So please be careful and read the questions carefully, right? So that you don't end up making that kind of mistake, I just noticed that looking at that slide, I probably wouldn't throw one in there that said Antarctic Sea, because there are some people who do call it the Antarctic Sea. I think I spelled that wrong. All right. So that's an example of that. Let me see. Here's one. Here's one that you might see. This is one. These are multiple choice, but I'm going to kind of treat them here as fill in the blank for you all. See if you can. So your answers would be a guess, hypothesis, a theory, a law, or an observation. So a tentative testable statement attempting to explain a natural phenomena is called, well, you can, yeah. I'm giving you an idea. I if you wanted to answer, by all means, sure, Amy. Yeah, there you go. So if I were going through and doing my notes, again, I would definitely want to make sure, because you may see something about the scientific method, and I would definitely want to write these steps down, and I want to make sure that in my notes that I have this information, right? Okay. Yeah, you guys can answer. I didn't mean to say you couldn't answer. I was just kind of letting you read it and digest it and getting you. I think some of the times, especially with a new professor, some of the early things with exams is the fact that students, aren't sure how I test or how a professor, how their exams are done. So here's another one for you. These are still out of chapter 1. Sometimes it's simple things like that. Yeah. So if you want to remember something like that, this is a good place for mnemonic devices. Mnemonic devices are knowing the oh gosh, the one that we used to have as kids. George eat old gray rat at Pat's house yesterday. George eat old gray rat at Pat's house yesterday. I was typing. I thought I was typing. That's how you spell geography. Okay. So here in this one, if I had a mnemonic device, I'd say, well, it's Pacific, Atlantic, Indian, and Atlantic. So it's PAIA, P-A-I-A. And that's how I would remember the order of the deepest to the shallowest ocean. And then at the end, if you wanted, you could throw in the Southern Ocean. So paellas. So it's kind of like that Spanish dish, paellas, right? Use mnemonic devices. That helps you remember order of things. That can help you with things like that. Okay, so whenever you come across stuff in your notes that are lists of things like that, or rankings or ordering of things like that, then that's how you want to put them together in your notes, and you want to get some sort of a little memory device to help you remember the order they go in. Memory's kind of like muscles, folks. The more you use it, the better it gets. Oh, here's a good one. This is the one I like to use because people aren't aware of this, actually. And I tell you what, I'll give you the answers for them. I'll type them in. The first answer would have been contagious disease, shipwreck, scurvy, or gunfire. That's the way you remember lines. Yeah, there you go. That's how you remember lines. Remember I told you about lines? I put the picture on so as you're going through the lecture slides like I got, look at all the little pictures and say, hopefully at the time you made some notes and add to your notes about what I was talking about there, because these are visual cues for me to remember. Oh, there was a lime on a page. It's scurvy, because scurvy is vitamin C deficiency. Remember? We said that's what some of the early sailors really had to deal with was scurvy and cabbage, which means, boy, it must have smelled good. But scurvy and citrus, if they could get it, and citrus was good for preventing scurvy. And that's where the derogatory, at the time, remember, derogatory term for the British came from? We call them, not we, but derogatory term, like maybe we did when we were fighting in the war, but limeys. That's a derogatory term for a British person. It comes from British sailors. Okay? So those little pictures on there, remember the whole idea behind determining longitude, and Harrison in 1837 was developing an accurate clock. You remember what longitude, how you determine longitude, no, this isn't on the exam, but anyway, remember I told you how you determine longitude is the difference in time between where you are when it's noon at your place and the time it is back at Greenwich, England. That's how they determine it. So I needed a clock for that. All right. Okay, let's do chapter 2. So that's a couple of questions, sort of an idea from chapter 1, right? And these are what you would be your multiple choice type. This is what you will call your multiple choice type questions. All right, here's a good one. Do you remember terms? This is more that structure and process terminology. Here's one for you. So this is a fill in the blank, but the answers would be A. Wish I could type faster. There we go. This would be B, because there's spelled these wrong. I'm sorry. I'll correct it. Oh, too many letters. Tell me by number: first, second, third, fourth, or fifth one. Okay, no such thing as a mesosphere. You got the order backwards, Sean. Tectonic plates are pieces of the lithosphere that float on the more fluid asthenosphere. The lithosphere, litho means rock. So the rock is floating on top of the liquid. I don't remember what astheno means. Astheno. Maybe I had it in there somewhere. Oh, wait, chapter 2. Right? So this is an important question to look at for the idea. You got to remember when you read the questions, there's going to be the detractors in there. Like I said, there's no mesosphere. But even if you see the answer, make sure you don't jump on or see the words, make sure you don't jump on it right away. It might be in an opposite order. No, just that these two are good enough. You don't need to know all of those. Right. So you got to make sure that you don't jump on these questions quickly, right? That you look at them and look. You got plenty of time. You got an hour and a half, and you only have 36 multiple choice questions, and then a few others and a couple of short essays. So, and you can always start the essay if you are anxious and worried about the essays. You can always do those first. Do the essays first, and don't forget about test mining, where that part of the information to answer the essay might be somewhere in one of the multiple choice questions. Okay, might be written out somewhere. So you're like, oh yeah, I remember that was in there. That just is a function of asking information or asking questions about the same information. There's going to be overlap, right? All right, here's another one. Okay, this is a multiple choice, but see if we can think it out. So the Hawaiian Islands are located on the Pacific Plate, and I told you how the way they were formed. And I'm giving you this much more information because the answers are too long, but if you saw the answers, this would be better in context. But what I'm trying to get at is the Hawaiian Islands are on the Pacific Plate, and the way they are formed, the arrangement of the Hawaiian Islands into, remember, an archipelago is suggestive of what's going on there, what's going on in that part of the world underneath the Pacific Plate. Now, do you remember what I'm referring to? Yeah, that's a hot spot. There you go, exactly. So that's a hot spot. What's a hot spot, Sean? Where's that one? There we go. Back. See, there's the Hawaiian Islands, right? They're formed in an archipelago. So the plate, we talked about this in class, the plate is moving off into this direction. And every time it passes over a hot spot, which is basically nothing more than a weak spot in the crust, right? So here's the lithosphere, the rocky part. Here's the asthenosphere down here. It's deeper than that. This is all the asthenosphere right here, but it's just a shallow area. The lithosphere is not perfectly the same thickness all the way around the Earth. So here's a spot where it's a little bit shallow. So here's a little hot spot. So every time the plate moves over that area, that hot spot causes volcanic activity because this stuff from below, this mantle plume, this rising hot rock and gas, as you can see in the picture here, punches up through the surface. Okay? Hotspots are nematodes. They're also called nematodes, which, again, I think is a cool word. All right, here's another type of question you might see. This is a question I like because it's a question that lets me discern how well you can separate what are common things. It's compare and contrast, and I love compare and contrast. Here's the question. Examine the 5 words, choose the one that does not fit. Okay, so I'm going to type the 5 words, and you're going to tell me which number does not fit. So let me type them first all before you start answering. Try to. There. All these are my Sesame Street questions. What? Sorry, that's 2 words. Volcanic arc. One of these is not like the other. Finally. So there you are. Continental or convergent plate boundary, continental arc, volcanic arc, island arc, rift valley. One of those does not fit. Which one doesn't fit? Great. Amy, why? That's correct. What do the other 4 have in common that's different in the 5th? Anybody else? Anybody want to help Amy? What's common about convergent plate boundary, continental arcs, volcanic arcs, island arcs that Rift Valley sticks out? What happens at 4 of them, or what's going on at 4 of them that's not going on in the 5th? The Rift Valley. Amy's correct. It is the Rift Valley. There's the Rift Valley. What's happening along the Mid-Atlantic Ridge? Tectonically, lithospherically. What's going on at the tectonic or the Mid-Atlantic Ridge? Are we forming crust at the Mid-Atlantic Ridge, or are we destroying crust at the Mid-Atlantic Ridge? Forming. This is drifting apart in this direction, right? So in areas where there's the Mid-Atlantic Ridge, and along any ridge, the Mid-Atlantic Ridge, that's right, the Mid-Atlantic Ridge is the more prominent one. The middle between the ridge, there's a rift valley, isn't there, right? It's not one mountain range. There's a rift valley between them. That's where the spreading is occurring. That's the rock going one way and going the other way. The other 4? Right, and then on the other side of the world, is that what you mean? Other side of the world? So in the Pacific? Yes. Oh, the other 4 choices. Correct. Yes, yes. Sorry, Amy. Yeah, so in the Pacific, Amy is saying that what's going on is the plates are coming together. I can't find a good picture, but right. For example, this is the Aleutian Trench. I don't remember the name of this one, but the Marianas Trench is down here. But that's where the plate, this plate's moving this way, is diving down below. And that's where plates are converging. Right, so that's those are convergent plate boundaries, and when you have convergent plate boundaries, you form things like continental arcs. I need one of the East Coast, the East Coast or the West Coast of the United States. A continental arc, mountain ranges. Okay, one plate, the Pacific plate and the North American plate. The North American plate is riding over top of it, and it's causing the North American plate to form. That's pretty good with my hands, to form mountain ranges. That's a continental arc. All right, and then volcanic arcs. Within those mountain ranges, you can have volcanoes from the heat plumes rising up. And Japan is an island arc, right? The plate is diving down below, and basically Japan is very volcanic. It's the rising of those heat plumes that's forming a land, right? It's like spitting a rock back up to the surface there. So yeah, in the Rift Valley, they're moving apart, and the other 4, they're coming together. Okay, so let's do another one of those. I really do like those questions. Oh, same one. Yeah, it's just a variant of the one we just did. Okay, here we go. Same thing. All right, same thing. The one that doesn't fit, I'm not going to put in the instructions again, but here they are. And okay, there you go. Good. Seafloor spreading, ice age, earthquakes, paleomagnetism, and the age of ocean floor rocks. One of those doesn't fit. Anybody else? Not quite. Not yet. Yeah, Ice Age. Why, Amy, why did you say Ice Age? I'm going to find that slide while. There we go. Does everybody see why it's Ice Age? Seafloor spreading, earthquakes, paleomagnetism. Paleomagnetism was that study that found out that the magnetic field on the Earth is reversed every 250,000 years. So if we look at the magnetic signature in the rocks, when rocks come up out of that Rift Valley and form, when they're liquid and before they become solid, those crystals are moving around, and those crystals then line up as they're formed. They line up based on the way the poles are, and then as the rock cools, they're fixed in place, and they can't be switched the other way. So even though the poles switch back in, say, another 250,000 years, whatever way those crystals are pointing into gray rocks, it stays that way. And whatever way it's pointing into brown rocks, it stays that way. So it lets us know that there's been polarity reversals. Now, what does that mean about all the other ones? That means that the seafloor is spreading, okay? And we know seafloor spreading, there's earthquakes along the mid-Atlantic ridges, the mid-oceanic ridges. There's a lot of earthquakes around the convergent boundaries where they're coming together, right? And this is paleomagnetism. Paleomagnetism and age of the rocks, these are all evidences of tectonic activity and continental drift. Ice Age is not that. Ice Age is just one of the geological ages that the Earth has gone through. That's all. Yeah, that's right. But it doesn't have anything to do with any of these other ones. Okay, another series of questions you might be presented with. Let me go. As I've been scrolling through the slides, every time I see it, I tell myself I want to stop and talk to you about it for a second. Examples of different types of convergences, like an oceanic and a continental convergence. And the example that I gave you was the west coast of the United States, the North American plate, and the Juan de Fuca and the Gorda and the Pacific plate. They're all part of the same thing, right? So you got to know what's going on in each of these areas. And remember that the plates that make up the bottom of the ocean tend to be more dense than the ones that make up the land plates. So whenever those two plates come together, like the one with Washington, Oregon, and the one with the ocean, it's typically going to, well, it's going to be the oceanic plate, the Pacific one, that's going to dive below the North American or the continental plate, okay? So it's going to subduct. See the picture down below? The Juan de Fuca plate, which is out over the ocean, is more dense. It's going to sink below the North American plate. And that's what causes, again, those volcanic arcs and those mountain arcs and those continental arcs is as that Juan de Fuca plate dives down, it's friction. Remember, there's a lot of friction going on here, and it's also getting hotter as you get down toward the center part of the plate or center part of the earth, so that stuff starts bubbling back up. That's what volcanoes are. They're like bubbling. They're like boiling rock coming up, right? Like if you were boiling rock. Okay, so know those different types of boundaries, the oceanic and the continental. Okay, here's an oceanic, the Puerto Rican Trench. And the Puerto Rican Trench forms an island arc. See those? This is what, the Windward and the Leeward Islands out in the Caribbean. Montserrat, Anguilla, St. Lucia, and all those islands, those are all part of this this island arc that forms because the Puerto Rican Trench is forming because this is diving down below the Caribbean plate. See where it's diving down? That's the trench. That's an oceanic. And a continental, that was the Himalayan mountains, right? And I think I showed you the picture of the Matterhorn, didn't I? Where like in the Matterhorn, you can actually see the rock, one piece of the rock pushing over top of the other one. This is what's happening because India is running into the Asian continent. Okay, transform faults when they move past each other, like out in California. So know the different types of faults and the way the plates are moving. Okay, so I could ask you things like the Mariana Trench is an example of what type of a plate boundary, and it could be oceanic continental, a convergent, a continental transform, an oceanic divergent. So I could mix all those up. So the Marianas Trench is an oceanic convergent. That word literally means two oceanic plates are converging. If it's oceanic continental, then it's an oceanic, like in a continental plate, like you see in this in the picture we saw with the Juan de Fuca plate. See, the Juan de Fuca and the North American plate, they're converging, right? The Juan de Fuca is diving down below, but the San Andreas Fault, this plate here, is moving this way. So that's why it's moving across, and the relative motion of the North American plate's in the opposite direction. Okay, that's enough for chapter 2. We're going to move on now to chapter 3. Oh, I'm sorry, chapter 3, excuse me. Okay, is any of this helping, or is there anything else? Is there something else I should talk about, or? Chapter 3. Okay, all right. I'll keep doing this then. Chapter 3, wait. All right, chapter 3 was marine provinces. Okay, so one of the first things we talked about in chapter 3 was how this information about what the bottom of the ocean looks like was gathered, right? These are things called soundings. And soundings are basically nothing more, especially in the early days, of just what's the depth. All we were basically getting was the overall depth, and the information was pretty sketchy, right? Because there's a lot of ocean out there, so they had to cover a lot of area. So what they switched over to as time has gone on is we've used things like echo soundings, especially when sonar was being more used in the early part of the 1900s, and things like echo sounders with digital technology, side scanning sonar. But the one I said that really, is one of the bigger ones is using information from satellites. Okay, and what's going on here with the satellites is because the ocean water is disturbed by these underwater mountains and structures, that there's bulges and dips into the ocean surface, just slight bulges and dips in the ocean surface. So satellites do a really, really good job of being able to cover a lot of area, and by reading those little bulges and those dips can tell us what the bottom of the ocean looks like. So this is where the big technology is there. So know some of those technology that are used to gather information about the ocean floor. And then okay, here's a question you might see, something like this if we're talking about the ocean floor. Okay. I might also show you a picture similar to what you see in the map and point to the Monterey Canyon there and ask you to identify what that is. Right? That's a submarine canyon. And what causes submarine canyons? What causes these big erosive scars? And there's a little picture down below that reminds you about what we were talking about turbidity currents, right? Big waves of material, water and rock that pour down the surface. Look how steep that is. So basically what happens is the canyon wall starts to erode in on itself, right? It erodes. It starts to fall in on itself. And these cause all this rock and water to flow, and it gouges out these big submarine canyons. They're called turbidity currents. So submarine canyons are formed by turbidity currents. Turbidity means how cloudy the water is. So the more rock there is in the water, the more turbidity there's going to be. Ooh, another one of these questions that I really like. All right, now again, let me put all the answers in before you jump into this. But read through that a couple of times. Only a few of these, so don't get too worried about seeing tons of these, but these are good questions. I do love these kinds of questions. They make you think into the higher thought processes, which I know you guys can do. Okay. This is a logic statement, right? Logic statement. So you might have to take a little bit of time with these. Not all the multiple choice questions will be quick, what's the deepest ocean? So you might have to read this a couple times. So what we do is we judge the following sentence, and there's some criteria below. There's an assertion, there's reasons, and then we talk about whether they're correct or they're valid, and you'll see what I mean. Let's look at this first one. We say that the continental slopes around the margin of the Pacific Ocean are greater than the global average slope because the Pacific Ocean is the world's largest ocean, covering more than half of the ocean's surface on Earth. Okay? So, let's take a look at the answers. Continental slopes around the margin of the Pacific Ocean are greater than the global average slope. Okay, that's true, right? We're looking at one right here. They're very steep, and then we say this is because the Pacific Ocean is the world's largest ocean, covering more than half of the ocean surface on Earth. And that's true too. So let's take a look at our answers. The assertion and the reason are both correct, and the reason is valid. All right, let's take a look at that. Is that correct? Is the reason that the continental slopes around the Pacific Ocean are steeper than any other place on the Earth on average because the Pacific Ocean is the world's biggest? No, of course not. Okay, let's look at number two. The assertion and the reason are both correct, but the reason is invalid. So both those statements are correct under their own right, but the reason is invalid. So is that correct? Well, the second one. It didn't type in the way I wanted to. Hold on here. Here's the second one. Maybe that's why you guys aren't answering. Assertion and the reason are both correct, but the reason is invalid, okay? And then the assertion is incorrect, but the reason is correct. No, the assertion is correct. Both the assertion and the reason are incorrect. No, see, the trick to understanding these questions is break them down into their parts, okay? So we're saying the reason and the assertion. So those two statements sitting alone are correct. The continental slopes around the margin of the Pacific Ocean are greater than the global average slope. True. The Pacific Ocean is the world's largest ocean, covering more than half of the ocean surface on Earth. True. But is one caused the other? No. So these questions can be a little bit tricky. So make sure you read them carefully. I've only got a few of them in there, so that's the only really example that I can truly give you, but you'll see some of those. All right. Back to some more straight up kind of questions and answers. All right. And your choices are now, this means you got to remember what are active and passive margins. Remember, the margins are the edges of the continents, and if you're moving away from convergence, if you're moving away from the spreading Rift Valley, then you're a passive edge, and if you're moving towards convergence, then you're an active edge. Active because that's where a lot of volcanic activity occurs. Trying to find. There we go. Okay. So the east coast of where? East coast of Japan or the east coast of the United States, Marissa? Yeah, east coast of the USA, that's right. Over in Japan, the continents are, so we have an active margins coming together. That's why we have convergence. But on the eastern coast of North America, the plates are moving away from one another. So that's a passive plate. The active plates will be over here on this side. So the active plates are going to be here. The active margins, the passive margins are going to be here. Oh, here's another one of those 5-word things. Let's do this one. Well, you know the setup for this. One of these doesn't fit. So here are the terms. Any answers? Why are you guessing? Right, I know, but I mean, what? Continental shelf, shelf break, continental slope, continental rise. Where's the abyssal hill? Do you see an abyssal hill? Careful reading the question, right? No. That's, you got to be careful reading the question. By definition, the abyssal is a plain. That's what it is. That's why we call it the abyssal plain. It's a large flat area that spreads out after you come off of a continental rise. So in that question, it's not so much like, well, gosh, aren't those all related to, parts of the passive continental margins? there's no such thing as an abyssal plain. It's like, do you remember what happens once you come down off the continental rise and you go out to the abyssal plain? You have this huge flat area. Remember, it's got sedimentation up to 1 kilometer deep. So even if it's not flat, it's filled in flat. It's this huge, massive. There are some rises through there, but be careful with questions when you're reading through them, okay? All right. A submarine at 100 fathoms, a submarine at a depth of 100 fathoms is how many feet? How many feet depth is that? Remember I said the name of this length got it from the way they used to measure the length of rope that they put over the side when they were doing their soundings. Yep, 600 feet, right? Remember I said a fathom, and you can't see my outstretched arms, but if you could, a fathom was when they would pull the rope up from below. They would say, okay, one outstretched arm is 1 fathom, 2 fathom. Now, my arms don't reach 6 feet, but the average, human back then, I guess, probably was 6 foot tall. Well, maybe they weren't, but regardless. So 6 foot it was standardized eventually. Okay, let's jump over to chapter 5. Remember, much to Amy's disappointment, we don't do chapter 4, but we do chapter 5. So here's one for you. Average salinity of seawater. Average in percent, okay? Here are the choices. Average salinity of seawater. Yeah, remember, it's not as salty as you think, right? It's a lot saltier than it really is, but the average salinity of seawater is only about 3.5%. Only about 3.5%. So, okay, there we go. All right. 35 parts per thousand is 3.5%. Because 35 parts per thousand is 3.5 parts per 100. You should know some of the basic constituents that make up seawater, right? And I'm not real worried about all of these minor elements, but I definitely would think it'd be important that you know that sodium and chloride are the 2 major elements that you're going to find in seawater. It's the same thing you find in any salt, right? That's why it changes, or that's why it tastes the way it does. Okay, here's another one related to this chapter, another definition thing, and your choices for this one are yep, thermo, right? Heat. Thermo. What's a halocline? For example, here's a halocline. Actually, it's just a latitudinal halocline. There's the halocline. A cline is anything that gradually diminishes, and halo means salt. Thermo means heat. Okay. Iso means same. So an isocline means there's no change. All right. Another one for you. Right. So your answers are, let's say, I'm just going to abbreviate. Ocean to atmosphere, continent to atmosphere, continent to ocean, atmosphere to continent, and atmosphere to ocean. So most of the water vapor in the atmosphere that causes the rain, where's most of that come from? Right, ocean, the atmosphere. Just think about the entire amount of ocean surface area there is. So there's an awful lot of water for evaporation to occur there. Right, absolutely. Know some basics about pH. Know what are acidic and what are basic pHs. You know, like anything above 7 is basic, and anything lower than acidic or lower than 7 is an acid. We did a little demo in class. You remember we took the we exhaled into some Erlenmeyer flasks that we had of that red solution that turned it yellow. And I was using that as a demonstration to explain to you why the lower pH level in the ocean is due to the process that it's due to. So the lower pH level in the ocean, if you remember, is caused by marine respiration, right? So the low pH level of the ocean is due to respiration. But what gas is that's given off that causes the lower pH level? What were we exhaling into those Erlenmeyer flasks? Yeah, right. Because here's what happens when you with the carbon dioxide, right? We exhale carbon dioxide, or organisms in the ocean respire and they give off carbon dioxide, and that mixes with the water, makes carbonic acid, and then carbonic acid is an acid. So it's a proton donor. Remember, that's what acids do. All right. So. All right. Hold on a second, folks. Let me calm Coop. Okay. All right. Here's one for you. And I'm gonna here's your answers, all in degrees, okay? Did you know that before you looked at the chart, Marissa? Good. And how did you know that? Right? One of the ways you could do it is by process of elimination. You know that 5 degrees is during the tropics, and there's a lot of rainfall that occurs in the tropics. You know, the higher latitudes, 85 and 65 and 80, even 45, you get a lot of precipitation and rainfall. What you get at 25, which is the Tropic of Cancer and the Tropic of Capricorn, is 25 north and 25 south, is you get a lot of evaporation, but not as much rainfall. So you get the heat, not as much as you get at the equator, but you don't get the rainfall that you get at the equator. Okay. All right, let's go into chapter 6 now. Take a look at some of those. Any more questions about anything in chapter 5? All right, and here in chapter 6, we talk about the Coriolis effect. And of course, that's real important. So I definitely want you to know what it is, be able to explain the Coriolis effect. It might be, for example, one of those questions that you see as an essay question. So it is something that is important for you to know. So here's a question, a multiple choice question about the Coriolis effect. See if you can figure out what this says, or see if you can figure out the answer while I move to it. There we go. So the answers to the questions could be to the left of their original direction or to the right of their original direction. So in the northern hemisphere, which way are the winds deflected? They don't. When the winds move down off the surface of the earth, they don't move in a straight line. Is that what in the northern hemisphere? So the kid throws the baseball to the guy standing on the equator, and in the meantime, the earth turns, and the earth turns this way. So that means in the time it takes the baseball to get there, the catcher, has moved off to the right. So which way did the ball go? Okay, so I mean, he's moved off to the pitcher's left, so the ball goes off to the right. So the winds in the northern hemisphere are deflected to the right. In the southern hemisphere, they're deflected the other way. Now, the way to always remember that is imagine yourself standing at the North Pole, and the wind is blowing from you down over the surface of the earth towards the equator. And if you have trouble remembering which way the earth rotates, and I'm not being facetious about this because sometimes I have to remember myself, remember that the sun rises first in Florida before it does in California. So the earth is rotating towards Florida. So when you're standing at the pole, yeah, that's what I'm saying. When we're discussing the Coriolis effect, the frame of reference is you at the North Pole. Yeah, that's right, Danielle. That's exactly what I'm addressing. So if you're standing at the North Pole, the earth is moving this way, and the winds are moving this way, so they're going to get deflected. And then the other way in the South Pole. All right, so always keep your frame of reference as you at the pole looking down towards the equator. Here's another one of those 5-word things. One of these does not fit. Okay, so here's one. Too far. So which one of those doesn't fit? The doldrums are also called the intertropical convergence zone. I think that's a cool name. Tropical. There it is. Well, let's type it out. It's written right there. The intertropical convergence zone. Anybody? Well, the northeast trade winds, the southeast trade winds, the westerlies, the polar easterlies, they're all winds, right? Remember why it took Magellan 3 months to cross the Pacific? Again, that thing like the line, this is making that visual reference. I put a picture of Magellan on here, so maybe that would stick in your head. Magellan took 3 months to cross the Pacific because his men came across through the intertropical convergence zone, through the doldrums. That's what the doldrums are called. And in the doldrums, what's happening right there at the equator, north and south of the equator, you're good because the wind's blowing you, right? You're moving actually pretty well, the trade winds. Not as well as the horse latitudes. Remember, the horse latitudes are called that because you're moving along really fast like a horse. But right there, that intertropical convergence zones, the winds die down to barely nothing. Took Magellan 3 months to get across the Pacific. That's a long time. No wind activity, absolutely. There you go. Okay. All right, 306. We need to get moving here. Let's do. All right. Let me. Anybody have any questions for me while I'm trying to figure out another? Well, let's take a look at some in chapter 7 then. I've already talked to you about the essays, so you're giving me information on that. Here's one for you. This is a good one because this asks more than one piece of information, right? So the answers are, forever if I try to type this out. Here, I'm going to copy and paste them. Here's the answers. So again, let me put all the answers in. Got them. Smarty. Well, that was easy enough for all that copying and pasting. Yep, surface ocean currents are driven by the winds, right? The wind blowing over the top of the ocean is what moves the water around, and that's what causes the currents. So, and of course, then as you guys figured out, they're modified by the Coriolis effect. And land, obviously, as the currents hit land, then obviously they're gonna be modified. Let me get chapter 7. One of my personal studies, what we're talking about. All right, what else do we got here? Oh, here's another one of those judge ones. Let's do this one. Here's the statement. Then give me a second, and I'll put in all of the in this time. I'll walk you through it. I'll let you guys just figure it out. That was quick. So the assertion is correct. Ocean currents have the potential to generate more power than the wind. Is that right? We did talk about this. We said absolutely they do. What was the number? I think 8 times more. Let me get to the very end there. Come on. Keep up. $800 times. So water moves slower than the air, but it is much more dense than the air. So the ocean currents do have the power to generate more power than the wind farms, but not because the oceans move faster, but because the water is denser. See, water actually moves slower than air, but it's 800 times denser. Right, so that's the benefit of the wind farm. So again, when you're reading those those kind of questions, those assertion and reason kind of questions, make sure what you're looking at are both parts correct and is one related to the other. That's right. Oh, well, there's always, yeah, in all of the new ones, that's the big thing. But those will be overcome pretty quick, actually. I mean, as battery technology is improving, in leaps and bounds, so it won't be too long until they get that part licked, and that'll be real nice. Because I mean, then we can have some way to store the energy that we can generate from some of these alternative energy sources. Here's another one for you. Well, yes and no. I didn't spell that right, but who cares? What's the Ekman spiral? Remember, the Ekman spiral is that idea that if the wind blows across the ocean, sailboats and objects move at an angle off away from the way the wind's blowing. It was an observation that people made, and they're like, what the heck is going on? The wind's blowing, due north. Why do objects, as the wind's blowing them across the surface of the ocean, why do they move off to the right? Well, the reason they do that is because of this thing called the Ekman transport. So as the wind blows over the top of the ocean, what it does is each layer of water drags the other layer of water below it. So, at the top here, the layer represented in the dark blue drags the layer represented in the, rose or pink, drags the layer represented in the green, the yellow, green, the yellow, so on all the way down. And the arrows get shorter, indicate the effect is less. All right, so the amount of force that the layer above it is applying to it is less as we move down through the layers. And every time you move through the layers, you move off to the angle a little bit, 45 degrees off, 45 degrees, all the way down until what you eventually get is theoretically moving 90 degrees off of the way the wind is blowing. Okay, now if you've had physics and you remember adding up scalar values, this is kind of where this comes from. But if you didn't, then don't worry about it. But the way we get 90 degrees off of this is the first angle is 45 degrees, and then each angle after that is less, and the force that's being applied is less. So when you add it all up, it's 90 degrees theoretical, but about 70 degrees out there in the real world. Okay, so that's the Ekman spiral. Here's one. This explains why the beaches on the East Coast are warmer than the ones on the West Coast. So warm currents flowing. And your answers here are and these kinds of questions, I would try each pair just to make sure. Yep, you're right. You're right. Here's how I remember this. If I have trouble remembering which way the currents go, I think about the Earth, I visualize the Earth, and I know that the way the currents flow is they're going to flow this way, and they're going to flow this way in that direction because of the Coriolis effect. Now, the way I remember which way they go is the prevailing winds are always from east to west across the equator, not the other way around. So it's always moving from east to west. So moving from east to west means that these things are going to move in that particular fashion right there. So when the question says the warm currents flowing from the poles, all right, on the eastern side of the eastern side of a continent. So if I could get the eastern side of the United States, there we go. So that means that this is rotating this way. This is rotating this way. So as the water moves towards Florida, it's flown through it's gone through the equator area, so it's warmed up. So it brings warm water up the eastern coast and flows towards the poles. So warm currents flowing poleward, going towards the poles on the eastern side of continents, make it warm and humid. Now over on this side, the currents go that way and that way. So that's why we get the colder climate in the Pacific Northwest, sort of what we call a temperate rainforest, and that's why you get the warmer climate and the Amazon and the humid conditions of South America, because it's bringing all that warm air, or in the Atlantic, it's bringing all that warm air from the equator down across South America. All right, let's see here. Okay. Here's R. Oops, too far. Here's the one I was just looking at. Sorry, I keep going back and forth. I'm trying to find that one slide. I keep. Just have it a second ago. There you go. That's my problem. Okay, so the equatorial currents that we're talking about move right along the equator, right? So which winds blow along the equator? Not right at the intertropical convergence zone, not along the doldrums, but right north and south of that. Those are the trade winds. All right, so the answer there is the trade winds. There they are, right there. Okay, so there's the equator. There's the southeast trade winds. All right, folks. Oh, let me give you one more. This is only because it's in our backyard. You should know this for sure. Where's the Sargasso Sea located? South Pacific, Indian Ocean, North Atlantic, South Atlantic, North Pacific. Remember, this was the one where they did the research on where the eels were migrating. I showed you the American and the European eel, and there we go. And I showed you what sargassum was. We looked at a sargassum fish. There's a sargassum fish. So what ocean is this right here? This is the Sargasso Sea. What ocean are we in right there? Yep, there you go. Okay, folks, I think that's about time. Yes. And I put her in contact, and they've been. She left a voicemail.